Marine Cloud is an HPC cloud-based application which estimates the production of electricity from tidal farms. It is based on numerical simulation of the sea state, which predicts 24 hours ahead. The experiment was led by OpenOcean, supported by Atos and Activion. OpenOcean was established in 2011 with offices in Paris and Brest. Its mission is to find innovative solutions in the marine energy sector. OpenOcean has created MetOcean Analytics, the first online service which provides on-demand analysis of energy production from marine tidal farms. The ocean is a harsh environment. Tidal farm park developers have difficulties in evaluating the profitability of their projects, as the electricity production depends significantly on the location and layout of the tidal farm.
We wanted to provide a reliable assessment of the energy potential within the Raz Blanchard, one of the strongest tidal currents in Europe, which is found in the sea off French Normandy. The challenge was to offer the simulation in less than 24 hours to meet the need for flexibility from industrial stakeholders. They wanted it for the next business day.
OpenOcean defined a specific online portal combining workflows for the simulation of elementary tidal farms using HPC computing. This infrastructure reduces the time taken by the simulation and its analysis by a factor of 5. Smart parallelization of the workflow and extended resources made this possible.
Using
HPC cloud infrastructure and parallelizing our entire workflow, the execution time has been reduced by a factor of 5. We've dropped the computing time from 1 week to less than 24 hours, offering a full analysis presented in the standardized PDF report.
Now, a marine renewable energy developer can use an online web portal for all the data and statistics they need and incorporate them into a report in less than 24 hours. The consultancy, OpenOcean, has become a software-as-a-service provider. Its revolutionary tool allows time and money to be saved in the marine renewable energy sector.
Today, OpenOcean proposes an innovative offer for the marine renewable energy sector. It has gained recognized experience in both big data and HPC cloud-based tools.
The Marine Cloud experiment faced several challenges during its 2 years of development. Nevertheless, the consortium composed of Atos, Activion and OpenOcean are today happy to propose an HPC cloud-based service for the tidal industry. This experiment has been a decisive step forward in OpenOcean's transition from a marine renewable energy consultancy to a provider of software as a service. One of the Fortissimo case studies was a cloud-based multi-physics simulation for MEMS microspeaker design and development. The partner in this experiment was uSound. uSound, a company based in Graz, Austria, is a fast-growing audio company developing a novel technology for personal audio applications which allows smaller form factor and improved linearity compared to state-of-the-art electrodynamic technology and enables automated production and assembly ideally suited for the high-volume consumer electronics market. A MEMS production run is expensive and time-consuming, thus very powerful multi-physics simulation tools are needed to predict the acoustic performance of the speaker and to reduce the needed production runs.
At uSound, we use high-complex multi-physics simulation to be able to maximize the product performance in terms of sound pressure level and linearity. Such models have to consider coupling between electronics, mechanics and acoustics, which quickly reach the limits of locally available computation power.
HPC offers the possibility to use a more detailed geometry without compromises, analyze and consider acoustical losses with thermos-viscous methods, and speed up the simulation and development process. The multi-physics simulation software was adapted to run on the HPC cluster directly over the native user interface.
The use of HPC offers the possibility of parallelization to reduce the calculation time of our acoustics performance calculation from about 1 day to 1 hour. Having no limits in computation memory also enabled us to use very detailed models, leading to a deeper understanding of non-linear effects affecting the product performance.
The use of HPC resources enabled USound the use of highly detailed models to get reliable results. Using exact models, €400,000 can be saved by skipping 2 of usually 4 design runs required until final production design is achieved. Time to market is also reduced by up to 1.5 years by skipping additional prototype runs, each taking 6 to 9 months.
USound sees high interest of the market for our new and innovative technology. Efficient simulation models and HPC enable us to be fast at adapting to customer demands in the versatile field of personal electronics and wearables, as well as to bring our products to the market.
To address the mobile communications market in full scale, further technology and product development are needed. The development of this next phase mobile speaker product is 50% faster using the developed HPC methods, and therefore allow USound to gain market share and react to customer needs in a timely manner. One of the Fortissimo case studies was a cloud-based HPC optimization of manufacturing processes. The partner in this experiment was Emo Oradiana. Emo is a Slovenian SME specializing in the production of tools and dies for stamping, particularly sheet metal, in the automobile and aerospace industries. Emo utilizes laser metal deposition technology, LMD. LMD is an additive manufacturing technology that enables the generic 3D printing of large metal parts. Additive manufacturing is a rapidly growing sector as it allows for complex components to be produced with short lead times. However, the lack of sufficient control remains a barrier as it can result in unnecessary reworking, waste, and an increase in 3D printing times. This reduces both profits and efficiency.
We aim to
overcome the current deficiencies in online monitoring and control of laser processing so that we can realize the full benefits of additive manufacturing and create better quality products.
Emo currently uses LMD. As part of this process, Emo needs to gather and analyze significant amounts of data. A new system has been developed in this experiment that exploits recent advances in artificial intelligence, AI, for image analysis and in data acquisition from images of the process.
Nova tehnologija, imenovana SIPLAN, predstavlja sodoben pristop k...
The new technology, called SIPLAN, is a novel approach to the online monitoring of LMD. It uses deep learning principles working on the Fortissimo infrastructure to enable online and real-time quality control and monitoring of key features such as dilution and clad height.
SIPLAN addresses the quality issues of LMD-created parts, putting Emo at an advantage, as they are the first to use the technology. The use of SIPLAN technology cuts production time by over 30%, as well as ensures production of higher quality products needing less reworking. Overall, there is a 20% saving in operational costs and a 30% reduction in lead time compared to traditional approaches.
In Emo's case, the 20% yearly savings are equivalent to €58,000, and the cut of production time for over 30% is equivalent to savings of over 2,000 machine hours per year. These savings will allow us to place ourselves more competitively in the market and service more customers.
3D printing and other additive manufacturing technologies have had a major impact on European manufacturing industry, allowing fast and flexible prototyping and part creation. This industry is home to many SMEs due to the comparatively low cost of entry, and it is growing fast. The result of this experiment will enable European SMEs to remain competitive in this rapidly growing sector.